Hello and welcome to the video tutorial presentation on uh, making project using for PIC microcontroller using MPLAB. So when you have installed MPLAB on your system, so you can get this particular shortcut created on the Windows, or you can open through the program files. This is the front end of the MPLAB. So I have used MPLAB IDE version 8.92. This is the latest version till today. When you want to create a project, I suggest you go through the project wizard. So go to the project, start project wizard. In the wizard it will ask you for the device for which you want to make the project. So there is huge list of ICs in the range in the series of the PIC microcontroller PIC 16 series. In that series we will choose PIC 16F877A microcontroller. Next it will ask you for the active tool suite which you want to use for the project. Whenever you are doing the assembly language programming, for that I suggest you go through the microchip MPASM tool suite for the project. You select that. Next it will ask you to create the project, so you can create the project. So you create one folder, so in that folder you can create the project. So presently I have a folder MPLAB PRG on F drive, so there I can create the project. So let us give the name to the project, as we want to create a program to simulate how a relay can be interfaced with the big microcontroller. So I give the name to the project as relay. This is my project getting saved in F colon MPLAB PRG is the folder. So now next it will ask you whether you want to add some existing files to the project. So presently I am not taking the help of any other existing files. I will create my own file for the project. So I will skip this particular step. So just I will click on next and finish. So this wizard has made this project ready to be created. So now this is the project window what you have. So now next is you have to write assembly language program. So this is the editor available, MPLAB IDE, and then here you are expected to type the program for which you want to do what we can say software interface, hardware interfacing, or some software programs may be there. So here you have to type these programs. So I have already one program which is for interfacing of the relay to the microcontroller on the pin port port B.0. So this is the code. Let us say you have typed all this code as per the requirement of the application. Then what you have to do is this project, this ASM, this file you have to save with the extension .asm. So in the project folder I used to save this file with the extension relay .asm. So this is my assembly language program. So whenever I save this with .asm, so the colors are changed, means instruction colors are different, data colors are different. Okay, so before building the target for this particular project, let us discuss a few things which are important to be understood for creating different projects using big microcontroller. So very first thing what I have used is list p equal to 16F877A. Now list is a assembler directive. It is used to define the processor. So you are telling the assembler that for this project what processor I am going to use, P is equal to 16F877A. Next I'm including a file which is p16F877A.inc. Now this file has a processor specific variable definitions. What it means, I'm using names of the special function addresses in my program. I'm not remembering the address. I don't want to remember the addresses of the special function registers. So instead of writing the addresses, I'm writing the names. So this particular inc file has one-to-one mapping between, if this is the name, then this corresponds to the address. So in your program you will be writing the names, and automatically those names will be converted by assembler to its corresponding addresses. One next you find is it is written config. So now what this config is a assembler directive. Again, it is used to embed configuration data in the asm file .asm file. The labels which are following the directive are located in the respective inc file. As I have included that inc file, so this assembler knows what these labels are. So these are the bits in the configuration word, so you can set and reset as per the requirements of your project by giving this particular configuration word. So according to this particular configuration word, a 14-bit format is formed, and that bit format is loaded at the spatial address 2007H in the peak microcontroller, and peak microcontroller will understand how user wants to configure the various peripheral features for this particular project. So this is the configuration word which will be common. So these things will be common almost for every project using assembly language programming for peak microcontroller. Then there is one section called as variable declaration section. So what I can do is, in my project, if I want some variables, I can make the use of the general purpose RAM locations as the variable. So instead of again writing the address for that general purpose RAM location inside the data memory, what I can do is I can give some names. So count1 will be the name for the data memory address 75. Now next is org. So this tells that whatever code you are writing, so that has to be stored from address 000H onwards. So there I write go to main, because I know that there is a interrupt vector address 0004H in the peak microcontroller, and which is common for all 14 to 15 interrupts of peak microcontroller. So what I do is I take care that if some interrupt occurs, then I don't want to entertain that particular interrupt. So in its corresponding interrupt vector address, what I write is retfie. So just return back to the main program. So in the main program, suppose some interrupt occurs, it will go to the interrupt vector address, but there, as I have written the instruction return from that interrupt subroutine, okay, just return to the main program. So you will come to the main program. Fine. Now something you find is redundant. Now this is our main program. So when I want to interface relay, so this is the program for interfacing of the relay. So what I do is I clear the port B bits initially, then I select bank 1 by BSF status comma RV0, because I want to deal with one register which is there in bank 1, and which is the TRISB register, which is the data direction register. So port pin, if I want to configure as input pin or output pin, accordingly you have to write either 1 or 0 respectively in the TRISB register. So presently I want to use the port B as output port. So what I do is I load 00 in the working register, and this working register contents are loaded in the TRISB. Hence the port B of the peak microcontroller is configured as output port. Now what I do is again I select this particular bank 0, because what next I have to do is I have to deal with the registers which are there in the bank 0. So RP0 is clear, means you will go to the bank 0. So now this is the heart of the program. So very simple program is I want to turn on delay. So what I do is I use BSF port B.0 B, 0. This is the instruction used to set bit 0 of port B of peak microcontroller where the relay is connected. So it is set, then I do call delay. So I will wait for some time. So it is a software generated delay routine we will be calling, and then after that delay again clear that, again call delay, go to loop. So if like this, if I check the pin pin port B.0 of peak microcontroller, what I expect is I will be getting a square wave on that. And then if I am connecting relay to the peak microcontroller, then that relay will be continuously on and off. Now let us go through the delay routine. So delay routine is a software generated delay. So what is done is a value ff is loaded in the variable which is already declared count1, and then I just go on decrementing that value from ff to 00. So microcontroller will require some time to decrement the value loaded in one register which is ff to decrement it up to 00. So that will give you some delay. If that delay is not sufficient, same thing can be repeated. So again I load that, so this, so that I can view that the relay is turning on and off. So this delay I have added, and then whenever I'm calling delay, I will come to this particular program, and then at the last instruction of this routine is return. So you will come back to the main program. So here I call delay, so I will go to the delay routine, and when I write return, the next instruction after the call gets executed. So this will make continuously on and off of this particular port B.0 pin, and if it is connected to the relay through the driving transistor, so that relay will be continuously on and off. So now what next you have to do is, after creating your assembly language program, so that program has to be added to your project. So go to the source file, go to the add files, and then this is the relay.asm. this file you are going to add to your project. So now this file is been added as the source file. So after that, what you have to do is you have to build the project. So it will ask you whatever code you want to make is should be absolute or relocatable. So you can have any option. Right now we are not going for that absolute or relocatable codes, but let us go for the absolute code creation. So it will it is giving you the message fine. So it is giving you the message that build failed. So you have to check where is the error. So error is showing is missing argument. So the arguments are missing. So the problem is this is coming to the next line, so it should be on this particular line. So fine, now I build the target. So now this is the most awaited message you get, build succeeded. So here you feel that your project is over, means you have got the output, but when you get the message build succeeded, it only means that whatever instructions you have written in your assembly language code, so they are correct as far as the syntax has been concerned. So to get the correct output, the syntax should be correct as well as logic applied should be correct. Unless until you apply correct logic for a particular application, never you will get the result. So here I get the message that build is succeeded, so I can trust that. So I am getting automatically a hex file created. So what you can do is you can check to your project, so where in F colon you have created the project. So this is mplab project is the folder. So now I can find that automatically a relay.hex file is being created. Now what I have to do is how I can check whether my code is working or not. So what I can do is I can have debugging of my code. So at this code, as this program involves a hardware interface, so there is debugger available, and in that debugger there is one option available is Proteus. So I can use Proteus VSM as debugger. Sometimes it is not, if it is not shown in the debugger window, so then you, if you have Proteus software installed, so you can open that Proteus software. So I choose that Proteus VSM as the debugger for this particular project, and then when I choose this, and then it will open one window. So here you are expected to have the design. So it is expected that you will have a project design, and then I will involve that design for this particular project. Presently I have this design file ready on the desktop, so I open this particular design file. So this is my design file for this particular program. So I can find that a relay is the microcontroller is there. So port B.0, a relay is connected to the driving transistor, and then to that relay bulb is connected. So what I expect is when the port pin goes high, the transistor will turn on, the relay gets energized, and when relay gets energized, I will have this contact switching from normally closed to normally open, and then this lamp will be off, and then when this I make this port pin 0, this transistor will be off, relay will get de-energized, and this will be the contact, so lamp will be on. So continuously lamp will turn on and off as per your program. So this is what is expected. So what I have to do is I have to check that whether I'm going to get that output or not. So what you have to do is, in this particular, as that of the microcontroller 8051, so this is a peak microcontroller, so here you have to give the path for the hex file, okay, which you want to execute. So presently we have created that hex file. in our project folders, which was there on f colon, so mplab project was there, and then relay.hex file. So this is the path I have given to the hex file. Now this hex file is available to the microcontroller, the design is there. So now what I can do is I can run this particular